So now let's talk about random number generation. So if you recollect, if you go back and check the range, or the few minutes before we discussed about a range, lin space. So if you realize, you know, what we are doing, we are trying to give some starting point, comma, end point. Then step size may be, number of elements may be, anything. So here we were restricting, right? I want number between this to this. And everything we know that what kind of a numbers it is going to come up with, because we know the starting point and end point. But now in the NumPy, there are some functions where we don't use starting point nor end point, because the numbers they are going to generate all random. We don't know what number it is going to generate. We'll have no clue about it, right? So yes, we have such kind of a functions in the NumPy as well. So how it is going to generate? What are those numbers? Is it going to generate a billions of billion number, or 0.000001 number, or what are those random numbers? Right? That's our next question. So for that, there are multiple types of a random number generation. First one is rand. Second one is rand-n. Third, rand-int. We'll discuss one by one and we'll execute as well. So if I say rand, it is going to generate uniform distribution data. So you may be wondering what is uniform distribution. So distribution and all we will talk in the statistics part, but here whatever necessary to understand, I will explain that, right? So the numbers are whatever the numbers it is going to generate, they all look similar to each other. When I say similar to each other, so there won't be, okay, number 1 and the next number is 22 some number, and the other number is 0.00. So you see there are a lot of a difference, right? So it doesn't make any sense. So what it does, it will keep that in mind. Numbers are very close to each other and all are positive numbers. Even it can generate negative also, right? Random number means, it doesn't mean that all are positive. It can generate negative. Yes, there are different functions for that. So what rand does, it will create or generate the numbers which are random, but it will maintain uniform distribution. We'll execute this and see. Right? Then after that, we'll talk about rand-n and rand-int one by one. Let's look into this. So first of all, how to use this rand function. NumPy dot random dot rand. So all then dot rand n, then rand int. So this is going to be same. So here we are going to learn 3 types with which we will be able to generate some random numbers. Let's start with rand. So I will talk about this seed, all right? So first let's use this np.random.rand. So again it is what? Rows, columns. So let's execute this. So first of all, let's finish this 10 rows, 6 columns, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. 1, 2, 3, 4, 5, 6 rows. So which is fine. Now let's look into this data. All these data are positive data. All are positive data. First thing. The second point is, if you look into any data here, suppose let's take this one and pick any data here. Let's pick this guy. How much difference we see, right? 0.22 and this is 0.25. And pick any data, this is 0.51. How much difference we see? They all looks uniform. If I take this data and plot it, suppose say, so if I plot it, so they look like this. Right? So it's 0, so start from 0, 0.1, 0.2, 0.3, 0.5. If I plot it, it is almost, if you see this is uniform. I don't have any data like one is here and another one is here. And the next one is here and the other one is here. Sorry about this line. So assume it is straight, right? So I don't have this kind of a distribution. So my distribution is always in this fashion. It is uniform. Very close to each other. Any number you take, compare with any other, you will not see much of a difference. Very close to each other. So that is basically what uniform distribution. I will talk more about distribution in the statistics class. All right. So at this moment, so this is what you can understand. What is uniform means. Now, coming back to this guy. Now what I will do, I will remove this. Okay. I will remove this and just make a note any one number in this matrix. Any one, your choice. I'm going to keep this guy line. Right? I'm going to monitor this. So what I will do, so let me write it, okay? So let me write it. Otherwise, next time we don't know what was the number earlier. So 19, give me a second. I will write it here itself. 0.22199,317. So this is the first number, right? So now what I will do, I will execute one more time. That number changed. Now it is .6353. Again, I will execute. It changed to 0.71. Once again, I will execute. Now it changed different number. Once again, I will execute. Changed. So you see every single time number is getting changed. Every single time. Why? Because everything is random. Everything is random. Now I have this seed. What is this seed? numpy.random.seed. So this number can be anything. You can keep 6, 100, 200, your phone number, door number, street number, pin code, doesn't matter. So these numbers always indicate that some randomness, some style of picking the numbers. If I say 5, so it has its own randomness. If you use this 5, you will also get the same number. Now I'm going to use the 5. Okay. Now let's execute this. Now you see this, we are back to the same old number. Because it has its own style. It has its own randomness, picking the numbers, choosing the numbers, or generating the random numbers. Even if you try the same rows and columns, you will also get the same numbers. Right? So that is basically what, if you don't use a seed, every time it is going to generate different numbers. If you want to keep any number, so it will generate every time similar type of numbers. And we don't know how it is going to choose this. That is basically what .seed. All right. So you see that the same number again came back. All right. So that is basically what rand is, which is going to generate uniform distribution data. You can change the number of rows and columns as per your wish. So that's about rand. Now how about rand n? Rand n. This is again a random number generation, but here you will not have all positive numbers. It can have a negative numbers, negative and positive. And how this data is going to be, how this data looks like. So it is going to generate the numbers such a way, if I take all those randomly generated numbers and plot it, right, in the graph, the data looks like this. Data looks like this kind of a distribution, which we call it as normal distribution. Again, it is a part of a statistics, right? The way it is going to generate the numbers, if you plot in the graph, it always looks like this shape. So that is basically rand n. So here you will see different explanation, zero, mean and standard deviation 1, right? So these are all basically statistics concepts. So I will explain at high level to make it very easy at this moment. Let's generate first. So here you will see a minus 0, minus 1, and minus 2, plus 2, and different things. 10 rows. I'm sure this part is clear. What is 10 and what is 3? I will not repeat again. I am hoping that you all are aware of that one. So this is going to generate some numbers. If I take all this data and I will plot it, the graph, it looks like this. So here it is 0, minus 1, minus 2, minus 3, plus 1, plus 2, plus 3. Right? So it will follow this kind of a distribution. So the mean of all this data. So what I mean, so if you add all this data, right? 1 plus minus of 0.10, you add everything, you are very close to 0. You will get the number very close to 0. Right? If you add everything and divide it by number of elements, so you will get a 0. Very close to 0. Maybe it is 0.0002 something, but very close to 0. Right? So that's what it says. All right. So rand n is going to generate this type of a data. So again, we are going to discuss normal distribution, which is one of the important topic in our machine learning and also in the statistics. All right. So here we are trying to understand how rand n is going to generate the numbers. Fine, that is rand n. How about the last one, rand int? Rand int. So here it works little different. So I am saying 5, 20, 10. So I am saying here, okay, first of all, let's understand how to write this numpy.random.rand int. What is int? Random integers. Random integers. In simple, I will write rand int. So here I am saying between 5 to 20, I want 10 integers randomly. You see what is random here? So what I'm going to do, let's try to understand. Suppose I have a bucket here, and here I have different colors of balls. Right? So what happens? So here you are going to Suppose say there are 20 balls. Then I will ask you to pick 10 times, right? Say 10 times. Let me take different color. So I will ask you to pick every time single ball 10 times. So you pick one ball, okay? Then again you will throw it back. I will note down, okay, first time you picked 0. Next time you are going to throw it back, again we shuffle. Again I will ask you to pick one more ball without looking into the bucket, right? You don't know what exactly inside. So again you will pick. So you may pick black again, you may pick green, red. So every time you are going to put it back that particular ball. So what is happening here? Every time you are going to pick the ball randomly. I'm going to shuffle this bucket every single time. So there is a chance, the point to note here is that there is a chance that you might pick the same black ball, right? There is a chance, right? You might pick the same ball again and again, maybe 2 times, 3 times out of 10. Just like a head and tail, every time you toss the coin, you will get a head first, right? Then again you will throw. Next time there is a chance that you might get a head again. Chance, right? So the same thing I'm saying, between 5 to 20 numbers, every time you pick up to 10 times. Number of samples to be drawn. So that is what I'm trying to say here. You might get repeated numbers, but everything should be inside 5 to 20. So you can see there are 10 samples drawn. We call them as the samples. Every time it is shuffled between 5 to 20, then again it will be picked. So if I execute this one more time, see, every time it is going to be different, right? So that is what I am trying to say. Between 5 to 20, I need 10 random numbers, 10 samples. Every time it's a fresh picking. You are going to pick the sample every time, the fresh. If you pick 14, again that 40 number is included in 5 to 20 again. You may end up getting the same number again and again. In this case, we can see here 19 is picked a couple of times, right? So that is how the random integer works. Let's take one more example. np.random.randint. So here I am saying 1 and 30, comma, here I am saying 6, 7. I'm sure most of you would have got the idea here. Whenever I say 6, 7, yes, you are right. So you pick random numbers between 1 to 30. How many samples? Here we gave 10 samples, which is fine, straightforward. But here I am giving the matrix size. You see a slight difference. I am giving the range of numbers, but I'm not telling how many samples. Rather, I'm giving you keep picking random numbers between 1 to 30 until you fill this 6 cross 7 matrix. How cool is that? So this is 6 cross 7 matrix. First time it will pick 1 to 30 randomly and it will put it here. Once again it will shuffle the numbers and pick one more number between 1 to 30 and next until it fills this 6 cross 7 matrix. After that it will close by itself. Right? Different ways of generating integers.